Hello, everyone. We'll be presenting our AUC Smart Personal Assistant using Federated Bots thesis project. The team is Donia Ghazy, Tarek Khalifa, Osama Wahsh, Mohammed Abuelwafa, Hussam Gawish, and myself, Nada Askar, under the supervision of Dr. Sherif Aly and Dr. Cherif Salama. Next. This is our agenda for today. Next. Starting with the problem statement, traditional bots have several problems. First of all, they are limited in functionality and use cases, which leads to frustrating the end users and decreasing the user experience quality and thus the quality of human-machine interaction. They are also unable to keep up with business needs, which decreases their overall operational efficiencies. Next. As for our objectives and motivation, in today's technological world, the need for enhancing the quality of human-machine interaction arose. And one of the key technologies in human-machine interaction is bots. However, bots end up decreasing the quality of human-machine interaction due to their previously mentioned inefficiencies and limitations. In a survey conducted in Italy in 2017, users were asked the disadvantages they faced with chatbots. And the most faced one was that they are not being understood. Next. In another one conducted in the US in 2018, the main problem was that it keeps them from a live person. These problems convey the frustrations of users and show how much these limitations affect the operational efficiency and the efficiencies of the bots. Next. Then we did a market analysis and surveyed the products in the market that were providing either bots or bot frameworks and compared them according to some of the features that we thought were really important in order to increase the efficiency of the bots. Examples are being code-based and being scenario-based and having multiple bots. These products such as Dialogflow with AI and Watson IBM. Next. And then we arrived at the solution. The solution was bot federation. Bot federation is having more than one bot that are communicating and cooperating in order to provide responses to the requests of the users. And this results in, first, a reduced scope for each bot, and this leads to better specialized trained agents and shorter contexts for each agent. And it leads to reducing the number of failed answers, which increases the quality of the human-machine interaction and increases the overall operational efficiencies of the systems and the businesses that are implementing these solutions. Next, Osama will be walking you through the first scope.
So talking about our first scope and tackling the issues that were mentioned before. Before starting, we need to define some terminology that are essential for our project. The first one is intents. Intents are basically the objective behind the user's utterance. So for example, if the user says that he wants to book a study room in the library, here the action of booking itself is considered as the intent. Next are the entities, and the entities are the subjects that are followed by the intents and the user's utterance. So for example, in the same example, the library would be considered as the entity. And if the user were to add that he wanted this booking to be at 3 p.m., 3 p.m. would also be considered as an entity. Next, the bot skill map. In our federation technique, we are relying on a bot skill map. Basically, we have each bot responsible for answering questions about one single intent, meaning that they only answer questions in one specific field only. And then the dispatcher, which is the orchestrator of the federation channel, would choose the most suitable bot from the skill map and delegates the answer to. As for our approach, we wanted to create a federated bot creation framework where the user would be able to create and instantiate any number of bots that they would want from some predefined templates. And if they would not find their most suitable bots in those templates, they would be able to create their own. We were able to create this framework using PyQt, where we have a GUI that would pass a JSON file, and then we would parse this file, and then we would instantiate that number of bots. And here we have a screenshot of the framework itself. On the top left corner, we have a login page where the user can log in with their credential. And on the right corner of the screen, we can see a screenshot of where the user would choose the number of templates of bots that they want. And on the lower left, on the lower part of the screen, we can see a screenshot from Discord, which was the platform that we chose to deploy our bots on. And we were able to make use of the Discord APIs, which were beneficial to our project, and in the way that we were able to, the APIs provide information about the ID of the user, so we can mimic an actual conversation between the bot and the user itself. And through this API, we're able to identify which bot were able to answer the questions that they were delegated to, and we can see if these answers were correct answers in the first place or not. Next slide. So our bot creation framework and how it works. Basically, we have an orchestrator that would delegate the utterance, takes the utterance from the user, and when our NLP engine processes this utterance, it divides the utterance to intents and entities, and based on the intent, the orchestrator would choose the most suitable bot to answer this question, and then it delegates the answer from the bot to the user, and takes command again, waiting for another utterance from the user. And now we're going to talk about our reason for change and why we wanted to approach this problem from a different perspective. In the beginning, we faced a couple of huge drawbacks, especially in the federation part. The first drawback is our NLP engine. So our NLP engine, our original aim that we wanted to have this framework available for clients from different backgrounds and different use cases. So we had to have an NLP engine that was specific for each use case, as well as data set that would have all the intents available inside use case. And the second drawback is not having enough literature about the federation techniques. So basically, through our research, we were not able to find any research on any products that are using any federation technique other than having a skill map. Some of them try to explore different algorithms for the dispatcher, and others only chose the most probable answer from all the bots themselves without changing the technique. And this is why we decided to go for a second approach, and now Donia will be talking about this approach.
So given the problems that Osama has just discussed, we needed to shift our scope a little bit. Hence, I'm going to explain to you our second scope. First of all, we are still targeting our original goal, which is comparing the usage of the single bot system compared to the federated bot system, and like addressing the problem that the single use system might face. However, we decided to focus on a single use case, which is the AUC community personal assistant, and the reason for that will be explained shortly. But this new scope allows us to show the usefulness of a federated bot task force on a community deployment basis. So basically, our system, as I said, it's a single use case, and this enabled us to develop a more specific NLP engine for the intent and entity extractions. It also allow us to have more available bots and stimulate the interaction between them. Of course, the system is just a proof of concept that can be extended later on. So basically, our design, we built a cross-platform for both iOS and Android using Flutter as a development framework. And the reason behind that is that Flutter uses Dart, and Dart has the ability to be compiled into JavaScript code. Second reason, Flutter is very simple and easy to use, and that has reduced our development time. Third reason, Flutter as its performance is very similar to the native application. And lastly, Flutter can work for both the iOS and Android. That is why there is no need to write two separate codes for developing the two applications. And for the database and the backend, we decided to use Firebase because it manages all the real-time data inside the database. So basically, the exchange of data to and from the database is very simple and quick. And that is very beneficial for us because basically our applications are developed based on the interaction, the real-time interaction between the user and the bots. And for the agent engine, we decided to go with Dialogflow. As Nada discussed in our market analysis, Dialogflow came among one of the top agents inside the market, according to different features, because it has like it provides more multiple bots, and it has API access, and also it's being contextually aware, and it has some personas, and it's scenario based and so forth. That is why we decided to go with Dialogflow. Then. So basically, these are the pages that have already developed in our application, like sign in, sign up, about, and fact. And the most importantly, the chatting system, which will allow the user to ask questions regarding the following offices, like the library, study abroad, CSE department, OSL registrar, and the sport complex. So basically, the rationale behind this chatting system is having an orchestrator bot that takes the user address and then it broadcasted to all the available bots inside the system. And after that, it gets back a score from each bot according to it's a specific trained NLP engine. And after that, that orchestrator chooses the best bot according to the highest bot, which gives the highest rank. And then send the answer back to the user. And the reasons of the choice of that federation technique, because basically it's already implemented in Dialogflow. And as I said, Dialogflow shows competence in the market. And also it's better than all the available bot implementation available in the literature. Because basically it depends on having like a rank for each agent instead of the one-to-one mapping, which might lead to misclassification at any point of time. Next. So basically what we are doing is just comparing the performance of the single bot versus the multi-agent. So as shown in the screenshot on the left, the single agent, we have just all the available intents inside a single bot, while according to the screenshot on the right, we have like sub-agent and sub-agent, like all the sub-agent have different intents, and these intents have specific entities according to its specific NLP engine, and then we ask them the same questions and record the answer to measure the performance. Regarding the back end, we use like a dummy database to store the extracted intent from the user input. Like for example, like here we ask like I want to book a study room at the ground at 5 p.m. So the extracted intent is like just the date time, which is 5 p.m. and the floor, which is type ground, and reservation type, which is study room. And now I leave the floor for Hussam to talk about the application and the demo.
Okay, so moving on to the application, our UI implementation design will be as follows. Next. So there will be an option for the users to sign in using their Google account. And after that, they will be redirected to the welcome or greeting page, in which by pressing the home button, they will be moved to the home screen, which gives two options, two buttons, either to press on the federated multi-agent system or there's a single agent one. And they have a sidebar navigation, which has three options: home, about, and frequently asked questions. Next. For the about page, it gives brief description about the project, as well as general knowledge about our supervisors and group members. And the frequently asked question will provide common questions that can be used for the agent to answer. And the last two images provide the UI application when the user are interacting with the systems, as well as general title description for either the user can talk to the multiple agent or the single one. Next. And now the demo will provide a comparison between the two systems, as well as testing the application and describe how it works.
Hello everyone, we'll be starting the demo for our application, the AUC personal assistant using smart federated bots. The first thing we'll be testing is the multi-agent bot. The multi-agent bot consists of 6 bots and an orchestrator. The 6 bots have specific tasks assigned to them, and the orchestrator will be broadcasting the utterance of the user to the bots, and then each bot will use its NLP engine to provide back an answer and a certainty score. Then the orchestrator will be broadcasting the message with the highest certainty score back to the user as an answer to it. We'll first start with the multiple bot. We'll first start with asking it, hi, who are you? As you can see, it says that it's, hi, I'm AUC personal assistant using smart federated bots. How can I help you? We'll be asking it to book something. So I want to book a study room in Plaza at 3 p.m. As you can see, it said, thank you, your reservation is made, and it's reserved it in the database. Another question for the OSL bot would be, how can co-curricular transcript be beneficial? And it answered me with the benefits of having a co-curricular transcript and what it is. And another question that this would be answered with the registrar bot. How many credits should I take to graduate? It answered me with the minimum number of credit hours I need. And another question for the study abroad bot. I have been nominated from an exchange partner. Do I still have to pay the tuition fees? It answered me with no and the details about this. And another question, but for the CSE department bot, I want to know the declaration GPA for CS. It answered me as well with the declaration GPA. And then the last question would be for the sports bot. Do I need to reserve a squash room to play in? As you can see, it answered me that it does not have to be registered. So it correctly answered all my questions, and each question was directed to was answered by the correct bot. Next, we'll be testing the single agent bot. This consists of only one bot that's responsible for answering all the questions given to it, and it does not have a specific area of focus. So we'll first start with hi, who are you as well. As you can see, it says, I'm your single AUC personal assistant, and how can I help you as well? Let's first ask it, I want to book a study room in Plaza at 3 p.m. So we'll be asking it the same questions we asked for the multi-agent bot. It made the reservation. And secondly, how can co-curricular transcript be beneficial? It answered it as well with a description about it and how it can be beneficial. And then how many credits should I take to graduate? It answered with, say that one more time, which is, it shows that it does not understand the question, cannot answer it well. So it goes back to this. Okay, let's ask it another question. I have been nominated from an exchange partner. Do I still have to pay the tuition fee? Sorry, I didn't get that. Can you rephrase? That was the answer of the bot, so it got confused. Okay, let's ask another question. I want to know the declaration GPA for CS. It answered it correctly with the declaration GPA, so it got back on track after being confused. Do I need to reserve a splash room to play in? This would be our last question for it. It answered it correctly as well. So as you can see, and as you can see, the single agent bot had a few problems or a few confusions. It couldn't answer a few questions, as opposed to the multi-agent bot that actually answered all the questions correctly. And this is it. Thank you very much.
So as Hussam just mentioned, we currently have an application up and running, and it's time for running our experiment and collecting the data. Next. So before any data collection activities started, regarding the ethical considerations, an intensive IRB training was taken by all team members, and IRB approval was acquired. Then the following was taken care of. First of all, consent was taken by all participants in either the survey and the focus groups. Secondly, all the identities of the participants were held anonymous, and their responses were confidential. Finally, the participants had the complete freedom to stop participating whenever they wanted. Next. Regarding the sample, both representative and non-representative methods of sample were used in this research. First of all, regarding the representative sample, this was to increase the accuracy of the results due to the fact of being the use case is a mobile application for a university smart personal assistant targeting the AUC community. Hence, a stratified representative sample from members of the AUC community were surveyed, and around 101 responses were acquired. Regarding the second non-representative sample, two focus groups composed of 3 to 4 undergraduate students from Ain Shams University and Cairo University were interviewed, and they were asked to assess the performance of the single agent compared to the smart federated bot system. This is the convenient sample in this research due to the fact of the participants not being members of the AUC community. However, they are university students with generally the same needs, hence their contribution and feedback was really helpful. Next. So how can we ensure that our data is not biased? First of all, the survey was launched online on Rate AUC Professors Group, and the survey targeted members from the AUC community from different majors and class standings, including students, professors, TAs, and staff members. Finally, the focus groups even targeted members of the non-AUC community who were asked to assess the performance, as I just mentioned. However, their contribution was just limited to the feedback and the suggested features, but not captured in the survey. Next. So now I'll be discussing the result. First of all, regarding the user experience results, our participants were asked to rate the performance of the users. Hence, we can find that around 95% of the participants rated it from 4 to 5, which indicated that they perceive the performance of our application as being like excellent. Next. Then they were asked to assess the ease of usage of our application, and around 92.1% rated the application from 4 to 5, which indicated that our application is very easy to use. Next. So they were asked if they faced any issues during using the application. However, around 95% of the participants mentioned that they faced no issues while using the application. However, we care about the 5%. Next. So we asked the 5% about the issues they faced during using the application, and mainly the issues were lack of trust. First of all, they preferred talking to a real person instead of talking to a conversational agent. And secondly, some users expressed that they would have loved to have quick buttons for commonly asked questions instead of like the ones found in other applications like Talabat, for example. Finally, some users found some issues with the single bot system, and I will analyze this shortly. Next, regarding the bots, first of all, we asked our users if they felt the switch between the agents and the smart federated bot system. As we can see, around 63.4% mentioned that they did not feel the switch between the agents. However, around 36.6% mentioned that they felt the switch, and that's a relatively big percentage. Hence, we asked those who did not feel those who felt the switch about their tendencies, since we designed our application for the switch not to be felt. So we asked them about their tendencies, whether they want to feel it or not. However, around 77.8% of them mentioned that they did not want to feel the switch. Hence, this informed us about that we need to enhance the transparency of the switch between the agents in our system. Next, regarding the accuracy of the results, we were amazed by the results, as we found around 98% of the participants rated the accuracy and relevance of the answers provided by the multiple agents as being from 3 to 5, around which only 5.9% rated it as neutral. Next. However, for the single bot system, we can see a left skewed histogram, of which around 67.3% rated it from 2 to 3, which indicated very low relevance or accuracy of the provided answers. Next, and now Tarek will continue talking about the community feedback.
Okay, so for the community feedback, we've got so much feedback from both the surveys and the focus groups. So first, we asked them if they believed that they needed such an application in their college lives, and 93% of the respondents said yes. Next, please. So for some of the suggested features that both the people from the survey and the focus group said, first of all, they wanted to have a map in the application to have the locations of certain parts of campus available to them. Next, they wanted to have a category to choose from, so a category of services. Next, they wanted a live support feature in case a bot can't answer their question, and they wanted a human to reply to them, or at least reply back later time. And finally, they wanted contact information for professors, information about courses, and so on. Next, please. Okay, so for some of the limitations that we currently have, so the first thing is that we use Dialogflow. So our application depends heavily on the bot's design and how we design each bot. And that brings me to the next point, which is that Dialogflow is currently in beta, so you can only use up to 10 agents per user. Second, the data we collected, the data you saw as the results of the bots, they were not 100% accurate. So for example, when you asked how many credits do I need to graduate, it said 120 without asking for your major. So we didn't focus much about the accuracy of the data. We focused more about how the bots respond and how they extract data. So for example, if you want to book a room right now, it will know that you want to book a room. It will know when you want to book it. It will know where you want to book it. But it will go to our database, our mock database. So it will go to Firebase. It will check the time. It will check the place. And if both are available, it will book your database. But that booking is not actually happening on the AUC server. So for that to happen, we need to access the AUC's APIs. So what we focused on more is how can we extract useful information from the sentences. And after that, we can use this information to do anything we want with them, actually. And the final thing is that the application is specific to AUC. So if you want to use the same application, you'll have to start and create your own NLP engine and edit it in Dialogflow, and you'll have to create your own agents from scratch. Next, please. Okay, so for the empowerment outcomes, we have two outcomes. The main outcome is the community deployment, is the application, and the second one is the research paper. So for the community deployment, next, please. So we currently have the Android application up and running. Anybody in the AUC can use it. And the application has both the single bot and the multi-agent bots, as you can see. Next, please. For the second outcome is the research paper. So we collected the data from the primary research, which was our surveys and focus groups, and the secondary research was our literature review. And with that, we've, along with our results from the application, we've wrote our paper that compares between the multiple agent bots and the single agent. To compare between them in the context of university assessment. Next, please. Okay, and we want to publish the paper in the ACM IEEE International Conference for Human-Robot Interaction. And that's it. Thank you very much.